so that you can see it. Clearly, if your X max is over here, you're not gonna see it. So keep dragging until you see that sucker cross the line. Okay? So far, so groovy? Okay. Which one's which? This has a positive slope, zero slope, negative slope. So this would have looked like this. So this will help you find a maximum. This has a negative slope followed by zero slope followed by positive slope. Your original function is going to look like this. This gives you a minimum. Questions? I highly recommend you put this on your cheat sheet. Which is how big, guys? 8.5 by 11, Matt's got it. 8.5 by 11, single-sided, handwritten, anything you want, anything goes, anything at all. And you get your tattoo as well. Woohoo! So by now, you should be happy about that, because that's, have you guys started using it every time you do your homework? Have you found it to be at all useful?
Yes.
Okay, good, good. There's only two other things I want to do on chapter 10. I'm going to whip through them real quick. And that's to remind you how to use concavity. How many of you guys hated the concavity section? Yeah, your hand's like, woo! Yes, it was awful. It was dreadful. All right, so I've done this for the kids in my classes that have come to my office. Yeah. And I did this for my other class, so Chandelier, you've got this set. Same for you, Memo. So just hang tight for a few minutes. I want you guys to take a look at this function. And we're gonna use the first derivative to find the location of critical values. So f prime shows where critical values are. It identifies their x. And then f double prime shows what they are. And we have three choices. We have maximum, minima, and horizontal points of inflection. So quickly, where is my first derivative equal 0? Tell me where. Here. Where else? Here. Where else? Right there. So now we have three places where we have identified critical values. This is a critical value of x, this is a critical value of x, and this is a critical value of x. So far, so good, guys? So we know where they are, but now we need to know what they are. And the way we do that is we take those critical values and we plug them into the second derivative. So if I plug this critical value into the second derivative, what kind of sign am I going to get out? Happy face, sad face, or a 0?
A negative.
Sad face. So where the first derivative is 0 and the second derivative is negative, that's a maximum, guys. And what about this one over here? If I plug this critical value into the second derivative, what kind of sign am I going to get out? Positive. So this is a minimum, which you can clearly see, right? So when the first derivative is 0 and the second derivative is positive, that's a minimum. What's the second derivative here in the center?
It's an inflection point.
It's an inflection point. So what's the concavity there, Maria?
It's 0.
Yeah, it's 0. So this is a horizontal point of inflection. So now on your tattoo, Russell. I want to remind you guys, son of a biscuit, I knew I had a spare one in here. So my language here is very deliberate. So if I plug an x into a function, I get out a y. Y's can be positive, 0, or negative. If I plug an x into a derivative, I get out a slope. Slopes can be positive, 0, or negative. A negative slope is a critical value. That indicates a maximum, a minimum, or an HPI. It says it right there. We don't know what it is though. In order to find out what it is, we plug it into the second derivative. Second derivative is concavity. Concavity can be positive, happy face, negative, sad face, or 0. And a 0 is a point of inflection. Notice I didn't say horizontal point of inflection, and I did that deliberately. Not all points of inflection have a 0 slope. This last one right here has a second derivative that's 0 right about here. But is the slope 0 there? No, it's not. So there's two places where concavity can be 0, an HPI or the point of diminishing returns, which is another type of inflection point. So how do you find the point of diminishing returns? Take the second derivative, set it equal to 0, and solve for x. Groovy? So take second derivative, set equal to 0, and solve for x. And that's it. Question or recording? You're good. Awesome. Thanks, Jesus. Any questions up here so far? Let me sort of like stand in the middle of them. Any questions, you guys?
That's how you find the concavity?
This, the second derivative, yes, second derivative is where you get concavity. If I'm asking you to find the point of diminishing returns, that's a specific kind of concavity. It's a concavity where the slope is non-zero, but the concavity is 0 itself, because it's going from concave up to concave down, okay? So here with the horizontal point of inflection, we have a 0 slope. Here, with the point of diminishing returns, we have a maximum slope, you guys. This is the steepest slope on this entire function. It's 0, it goes up, it maximizes, and it starts slowing down again. So two different types of inflection points, two different results, okay? How do you guys feel about this?
What's the I still didn't understand what is HPI and the diminish.
A horizontal point of inflection has no slope
Okay.
and no concavity, because you're going from concave down to concave up, okay? But you're also flattening out at that point. So look at the visual difference between
Yes,
that point and this point.
Yes.
One's flat, that's
Yeah.
horizontal. One's not flat.
Yeah.
That's the point of diminishing returns.
Oh, okay. Thank you.
How do you guys feel about these? Better?
Mm-hmm.
So if I give you a problem really quickly and ask you to find maximum, minima, and horizontal points of inflection, and we do it together, do you think you'll feel good about it? Okay, so those of you that have been in my office, hang tight, you've seen this problem before. So it's a good review for you. The rest of you, this will be the first time you've seen this one. This is one of my favorite ones because it's quick, it's easy, and it very easily demonstrates the where and the what. Okay. Execute. x cubed minus 6x squared plus 12x plus 1. And I want you guys to find maxima, minima, and points of inflection, if they exist. So remember, f prime shows where those critical values are. So let's take the first derivative. What is it?
3x squared minus 12x plus 12.
Okay. Groovy. Now what? Set it equal to 0. And while I'm at it, I'm going to factor out a 3 so that I can easily factor this puppy. So if I pull a 3 out of the first term, what's left? And if I pull a 3 out of the second term, what's left?
4.
And if I pull a 3 out of the third term, what's left?
4.
Plus 4. So now I'm going to divide both sides by 3, canceling that one. And I get 0 equals x squared minus 4x plus 4. Can you guys tell me what multiplies to positive 4 and adds to negative 4? I heard it. Not 2.
Negative 2 and negative 2.
Negative 2 and negative 2. So 0 equals x minus 2 times x minus 2. So what does x equal? Yeah, x equals 2. So we only have one critical value here, right guys? X equals 2. So far so good? Now, what is this critical value? Is it a max, is it a min, is it an HPI? How do we find out?
Plug it into.
Plug it into the second derivative and look at the sign of the answer. So what's my second derivative? 6x minus 12. And now I plug my 2 in right here. Equals 6 times 2 minus 12 equals what? 0. X equals 2 is an HPI because it has a slope of 0 and a concavity of 0. And if I were to graph it, guys, here's what it would look like. Because you always have the option to graph it to check your work, because why not? Why wouldn't you? Here's my x equals 2. It's got an HPI right there. No max, no min.
When you said when you have a slope 0 and a concavity 0.
What? When I have a slope 0 and a concavity of 0, it's
Yeah.
what?
It's an inflection point.
It's an inflection point.
But on
What
the
kind of?
board, which one can you point out? Because
What do you mean, which one? Which
so
one what?
0 is equal to x minus 2. That is my slope, right?
Slope was 0.
Yeah.
I've assumed my slope was 0.
Yeah.
Because that's where you find critical values, is where the slope is 0.
So f prime is 0.
Mm-hmm. I solve for my x's.
Yeah, and then
In this case, I only get 1.
and then I have f double prime, but I have f double prime as 2.
No, I have f double prime as 6x minus 12. I plug 2 into that, and I get 0 as an answer.
And that is what I'm looking for.
I'm looking for the answer, or specifically the sign of the answer.
Oh,
If it were positive, that would be a minimum. If it were negative, it would be a maximum. If it were 0, it's an HPI.
thank you.
Okay?
Can I ask a question?
Chandelier and Helena. Chandelier,
Can you graph the second derivative?
can I what?
Can you graph it?
Absolutely.
Okay.
Yeah. This is a positive line.
Okay.
Yeah.
Like on the calculator?
Yeah. You can totally graph it.
Okay.
And where it crosses the x-axis is going to be at x equals 2,
Okay.
because that's where concavity is 0.
Alright.
Helena.
I have like 3 questions.
Absolutely.
How do you get x minus 2 times x minus 2 out of
So the process for factoring here is what multiplies to this number and adds to this number. So -2 and -2 multiply to 4 and add to -4.
Okay.
If you were to FOIL this out, you would end up right back here.
And then how do you get x equals to 2?
Well, my terms I said equal to 0, but since they're the same term, I'm gonna get the same answer out, right? So x minus 2 equals 0, what does x equal? Yeah, so the step in between is x minus 2 equals 0. So then I just solve for x. X equals 2. What's your other questions? I see Christina. That was all of them?
Yeah,
Okay.
for now.
Okay, Christina.
So what's the difference between
They're not the same because one has a non-zero slope and one has a zero slope.
So if it equals to 0, it's HPI. If it equals to any other.
If the slope is 0 and the concavity is 0, it's an HPI.
Oh, so the F prime would be a number.
Nah, F prime is 0. Its concavity is 0 here, guys. Look, you've got concave up before that point, concave down after that point. So the concavity is 0 at that point. Just like here, it's concave down followed by concave up. There's a change in concavity there, but this one also happens to have a 0 slope. So on your tattoo, once again, where slope is 0, that gives you a maximum or a minimum or an HPI. Okay? Concavity can be positive, negative, or 0, and 0 gives you that point of inflection. Okay? But I specifically didn't say horizontal point of inflection because the concavity being 0 gives you two kinds of points of inflection. They're differentiated by their slopes. This one has a non-zero slope, this one has a 0 slope.
So how would you see that in the graph? Or would you just have to graph it?
Okay. Yes. That's a whole bunch of yes. Point of diminishing returns. Crap. You would see this in the math, because if you took this, the first derivative, and you set it equal to 0, you wouldn't get this point. You would get this point and this point. Okay? This is not a critical value for slope. This is a critical value for concavity only. Okay? This one has critical value for slope and concavity. Okay?
Okay, yeah, I got that.
Groovy. Okay.
Because one is just F prime and one, like, the reason
This
the
one is
graph
a
on the
critical
left has
value.
it for both is because
Yes.
F prime and F double
And
prime.
this one would be
Both equal 0, yeah.
0.
And over here, it's only F double prime that equals 0 at that point. Helena.
Nice. You
So
already
you would
answered it.
this step.
How do you know
Except
it's the
like these.
horizontal point of inflection?
How do I know it's what?
Like the x equals 2, you say it's the horizontal point of inflection.
Okay, so on your tattoo, you guys, it starts out with slopes. The slope part says slopes can be positive, 0, or negative. A 0 slope indicates a maximum or a minimum or a horizontal point of inflection. So now we go to the second derivative to tell which one it is. Okay? If we shove that number, whatever we found in the first derivative is our critical value, if we shove that into the second derivative, if it comes out 0 as well, that's a horizontal point of inflection. Horizontal points of inflection have no slope and no concavity. They're just a little flat spot where nothing's happening, except everything's happening.
But it's not 0, it's 2, right?
No, the x value is 2. The slope is 0, the concavity is 0.
So because there's no like 2 squared or something, that's why? Because it's just a 2?
It's just a 2. When we set a slope or a concavity equal to 0 and solve for x, we're not gonna get anything squared out of it. We're gonna get a value, we're gonna get an x value.
So how do you find maximum?
If you plugged that number, if you plugged whatever your critical values were into your second derivative and you got out a positive answer, that's a minimum. It's built into the picture of it, right? There's a minimum in that little happy face, isn't there? Okay, so minima have this profile, a 0 slope and a positive concavity. If you plugged that critical value, that x value that you found in the first derivative into the second derivative and you get a negative answer out, that's a maximum. That pretty little picture, that sad face there, has a maximum value to it. So it's all about how you get, or what answer you get out of the second derivative. Is it positive, is it negative, is it zero? That tells you what it is. Yes?
You can get like multiple maximums and multiple.
You sure can.
So I have a question. It's x minus 2 is equal to 0, right? Or x is equal to 2. So there's another one when we look at 0 is equal to x minus 2, and
what
then
does
we
that
have an
equal,
x
Maria?
minus 2.
X equals 2.
It's just 2.
2.
So can you not, what about the other x minus 2? We forget about
It's
that?
the same x
Okay,
value.
so we don't just put another 2.
No, because
Okay.
why, what's the point? You
Okay.
already identified 2 as a critical value.
Okay, okay, that's, I could make a typical mistake right there.
Okay.
Thank you.
But you would still get the same answer out. If
Okay.
you did it twice, you're just doing it twice. It's gonna
Yeah.
give you the same answer no matter what.
Thank you. Thank
Okay.
you very much.
Jesus.
I understand, so like if I get two x values, and one of them is positive and the other one is negative, then it'd be, diminishing returns, right?
Help me out. I'm not understanding what you mean by getting two x values that are positive and negative.
One of them was,
I need to hear him, guys.
one of them was x minus 2, and the other was like x minus 3, so I would get x equals 2 and x equals 3.
Then you would plug them into the second derivative, and depending on what you got out, that's what they are. So if you get out a positive answer, it's a minimum. If you get out a negative answer, it's a maximum. If you get out a 0, it's an HPI. Yeah. Point of diminishing returns, you skip right to the second derivative. This says nothing about the first derivative, guys. It says nothing about the first derivative. If I'm asking you to identify critical values and what they are, you need the first and second derivatives. If I'm asking you to find a point of diminishing returns, just skip to the good stuff. Okay? Any questions? You sure? Okay. The last thing I want to say here is I'm expecting you guys to be able to graph this. I want it to look like this elongated S that starts at the bottom and goes all the way to the top. Obviously, if you just drew this on the test, that doesn't tell me if you know what it is or not. So I want your X min, I want your X max, I want your Y min, and I want your Y max out of those things. So I can see the scale that you use to find it. Groovy?
Can you just use your calculator to, like, I know you can do it to find the x min, x max, but you can use it for y min and y max as well.
Well, you have to identify those Y min and Y max in your window.
Uh,
But that's you. You have to play around with it until it looks like this. But then I want to know what your numbers are. If you just draw the graph with no context, I'm gonna mark it wrong.
So you want what we put in the calculator to get that?
I want to know your window.
Okay.
I know what you did to get this. You
Yeah.
graphed the original function.
Yeah.
But I want to know the window that you graphed it in. Okay? All right. That's chapter 10, you guys.
Thank you.
You're welcome. I want to briefly go back to chapter 11. Chapter 12 is still pretty fresh in our memory. So I want to reach back to chapter 11 for the remaining 15 minutes. In your first test, you had a section called quick derivatives. In this test, you're gonna have a section called quick derivatives and integrals. RTFQ, folks. If I ask you to find y prime and you integrate, I'm gonna take all your points. Save 1 or 2 because you wrote something down. Don't do the wrong thing. Am I asking you to find a derivative or an integral here?
A
Derivative. So how do I do that?
Make it pretty first.
Make it pretty. How do I do that?
Ln x 6x cubed minus 12 raised to the power of half.
Okay. So the way we use our tattoo is we start at the beginning. If I ask you to find a derivative, go to your derivatives. This is clearly gonna be natural log of something, so it's gonna be derivative number 4. But is that something an easy, biteable, derivable thing? No, because it's a power, you would have to do d out dn on it. So is there something on the right-hand side of the tattoo under logs and exponents that can help you tear this apart so that you can take an easy derivative? And if so, what is it? No, no e's necessary here. Nikki, move the power down in front. Natural log of m to the p equals p natural log of m. Now while I'm at it, guys, let me ask you something. Is that the same as this? Yeah. What's the base in each case?
4,
And what's the exponent?
3.
Okay, so if I do natural log of 4 quantity cubed, is that the same as natural log of 4 cubed?
Yes.
Yes,
Unless there's a function involved that changes, or
not quite. Is this one the same as those? Natural log of 4 cubed.
No.
Why is that not the same? What's being cubed now?
Everything.
Everything, including the natural log, so this one is not the same. Learn to recognize the difference, right guys? So yes, we can use the n to the p power on this. So I'm gonna rewrite this as y equals 1/2 natural log of 6x cubed minus 12. So now is this a biteable, derivable function? Is it an easy u so that we can take u prime? Yeah, what is it? Over,
6x cubed minus 12.
and that 1/2 goes along for the ride because it's now a constant coefficient. And you're done. Of course, if you wanted to treat this like d out dn, you could. It's just gonna be a lot messier. Okay?
How would you solve the one that you said ln times 4 over 3?
We're not gonna go there.
Okay.
Okay. I just wanted to show it to you for this
Okay.
versus this. By the way, the natural log of 4 to the 3rd power is just a plug and chug. There is no solving, you just plug it into your calculator,
Oh, okay, good.
right?
Oh,
There's no
thank you.
x. So you would just shove it into your calculator and
Okay.
call it a day.
Thank you.
You're welcome. What about this one?
So you have a product rule. Because you have 2 functions.
So give me a thumb if you see that this is a product. All right. What's my u then?
It's 4.
Globally. What's my u? And globally, that's my v. So u prime is gonna be 9x squared. And v prime, we use the process for e to the u, which is gonna be 8x e to the 4x squared. Because here's my e and here's my u. So I use u prime, e to the u. just plug and chug. So my derivative is u prime times v plus u times v prime. Yeah, Riley. How did I get 8x? So remember, the process for e to the function is the derivative of the exponent times the original function. So my derivative of 4x squared is just dropping down in front. Does that help?
Yeah.
Okay. So this is a nested function again, guys. We've been doing these since chapter 9. Outside, globally, we have a product. Locally, we have a straight derivative on u and an e to the u on v, right? Okay. What about this one? Can I erase the first one, guys? Okay. And I ask you to find y prime. So I'm looking for a derivative here. So let's walk through the derivatives. Let's try to figure out which one it is. Can it be derivative number 1? No, why not, Justin?
Because 3x squared is not constant.
Yeah, 3x squared is not a constant. More than that, 6 is not an x. Groovy. Can it be derivative number 2?
Yes. U to the nth power?
N is a constant. Is our exponent a constant here? Nope. So can it be derivative number 3?
I think so.
No, there's no E.
There's no E. No E, no 3. Can it be derivative number 4?
Yes. No. There's
No.
no ln.
There's no natural log. So you've just cruised through all your derivatives and none of them work. So now look over on the other side for logs and exponents. And instead of thinking of these as natural log of e to the x or natural log of m over n, think of these as natural log times a function, or e to a function, or a to a function, or a constant to a function, or something like that. So what do we have here? We have a what to a what?
Product rule?
Constant to a function.
We have a constant to a function. Is there anything on your tattoo on the right-hand side under logs and exponents that helps you?
It's ln m
No,
raised
there's no natural log, Maria. Yes, a to the u.
Oh, I see.
A
Yes.
constant to a function.
Yes, yes, I see.
So what's the derivative, guys?
U prime is equal to
6x.
6x.
And what's the next part? 6 to the 3x squared. That's the original function.
3x cubed you put down.
Or 3x squared. My apologies. Maria. That was quick, Maria. And then what's the last part of this?
Are
Right
we,
there, guys.
are
All
we
you have
doing a
to do-
chain rule?
Thank you. Natural log of 6. All you're doing is filling in blanks, guys. Don't overcomplicate this. A to the u, when you take the derivative, becomes u prime times the original function times the natural log of the base. All I'm doing is filling in the blanks. Don't overthink it.
How did you get the ln of 6?
Look at your tattoo.
Because I use y is equal to a to the power of u.
Yes.
Why didn't I use a to the power of x?
Is this just an x?
No, it's got
more to it than that.
thank you.
You're welcome.
So where did you get the 6x and 5?
That is the derivative of your exponent. That's your u prime.
Thank you. This one's a little tricky.
It's a little tricky, but you also had one like this in your homework,
Yeah.
didn't you? You guys remember it? How many of you haven't done your homework yet? I'm getting a lot of blank stares out there. That's not good. Cramming bad, guys. Cramming bad. Cram bad. It's like, don't look at me. Don't look at me. Don't look at you. You guys okay with this? What about this one? I got a couple minutes, I'm gonna use them. What's the derivative?
It's the ln of e raised to the power of x is equal to x.
So what is this equal, guys? So what's the derivative of 12x squared?
It's 24x. So did we use the one which is ln of e to the raised to the power of x?
Yeah, that's absolutely what we just used. Natural log of e to the x is just x. Here's the thing on the, so I don't know if it's parenthesized or not, but it doesn't matter. Natural log of e to the x is just x. This is not a derivative, this is a simplification. I think that's very clear on the tattoo. Not a derivative, just a simplification. So you still have to go through and take the derivative. But that's an easy step. So really quickly, because we're out of time, on your review sheet, understand how to find f double prime. Great, we did that. Know which functions hold y, slope, and concavity. Right at the top of your tattoo, guys. Be able to use test values and critical values to ID regions of slope, concavity, maximum, minimum points of inflection. You won't have to do test values, just critical values. I'm not going to make you do those slope charts or concavity charts. Just like we did on the board earlier, just use the critical values. Know how to find max profit, etc., and points of diminishing return. We also covered that. Be able to set up a graph in a window to properly show points of diminishing return. I talked about that as well, okay? Chapter 11, understand relationships between logs and exponential functions, all along here. Be able to use tattoo to rewrite logs into derivable form. We talked about that. Know how to recognize and perform various derivatives, peeling the onion, like this. Globally, it's a product. Locally, you have two different operations to take the derivatives. And then be able to use logs and exponents and applications. That kind of goes without saying. Chapter 12 should still be fresh in your mind, but just remember the stuff at the bottom. Not just fixed cost is not always K. K is not always equal to 0. You must walk through the process using your nugget to find your K. You must, every single time. Okay, guys? Go get 'em.
Thank you.
You're welcome. I'll be around.